Welcome back to the deep dive. We're here again, sifting through stacks of reports, research notes, basically distilling it all down for you so you get the essential knowledge you need for what's coming next in tech. And today we are definitely moving beyond the usual suspects, not basic automation, not the chatbots you ask for recipes. We're even moving past the copilot idea.
Yeah.
We are diving into true autonomous systems. Agentic AI.
That's exactly it. We've looked at sources from, AWS, IBM, Deloitte, key research papers, and they're all pointing to one thing, a really massive prediction, actually. Agentic AI isn't some far-off sci-fi thing. It's positioned as the transformative force, the one set to fundamentally change business in 2025.
Okay, 2025, that's soon. So let's unpack that. And let's set our mission for today. We've all seen the headlines, right? The hype, robots will do your taxes, AI folds your laundry. Maybe someday. But our job right now is to cut through that. We need to get real about what agentic AI can actually do. What's the architecture, the deep stuff that makes autonomy work? And maybe most crucially for anyone thinking of adopting this, what's the governance needed? How do you manage these things successfully? We want to give you the insights that separate the serious players from, well, those just tinkering with the latest Gen AI toys.
Right. The big idea here, the thread running through all our sources, is that this agentic AI is a genuine step change, an evolution. It's not just, slightly smarter software scripts. It's a leap beyond traditional automation that was all fixed rules, and it's even beyond the first wave of generative AI.
So how is it defined? What makes it such a significant difference?
These systems, they're called autonomous because they're built with three core things in mind. First, they perceive their environment. They take in data. Second, they make complex, goal-oriented decisions based on what they perceive. And third, they actually take action. They use tools, external systems, to achieve specific goals. And crucially, without needing a human to sign off on every single micro-step, they bundle reasoning, memory, and action together.
It sounds less like operating a tool and more like managing a team member. Almost.
That's a great way to put it. And if you look at how we interact with it, the whole model flips. This is what people mean by the do-it-for-me revolution. Instead of you, the user, having to map out every single step in detail, the old do-it-yourself way, you just give it the high-level goal, like research this competitor set, draft me a risk analysis, and book a follow-up. The agent then takes the initiative, it figures out the how.
That shift, moving from being the detailed instruction giver to being the supervisor who sets the objective, that feels huge. And that timeline, 2025, it feels incredibly fast, especially considering how recently LLMs kind of exploded into public view. Why 2025? Why the sudden agreement on that specific year?
Well, the consensus seems to be driven by just exponential progress in the underlying tech. The models themselves, the tools they can connect to, it's moving fast. It's not just theory anymore. IBM, for instance, they shared results from surveying about 1,000 developers, people actively building enterprise AI apps now, and the number was pretty stark. 99% of them said they're currently exploring or already actively developing AI agents.
99%. Wow. That's not a niche trend. That's basically everyone in that space looking at this. It feels like the dominant direction.
The momentum is definitely there. You see it reflected in the media, of course. Lots of headlines about the age of autonomous AI arriving. But, and this is a big but in the sources, we have to be careful, there's the hype cycle, right? Often promising things that are maybe level 4 autonomy, full independence right now. The reality for secure, governed enterprise use today is likely a bit more grounded. We need to distinguish capability from clickbait.
Okay, so grounding the excitement is key. What's the sort of technical foundation we need to grasp for successful implementation?
The core idea seems to be moving beyond just thinking about the large language model, the LLM, as the whole solution. LLMs give you the reasoning, the brain, but they're not enough on their own. The focus now is on building compound AI systems. Think of architectures that bolt the LLM brain onto other things, databases, specialized software tools, memory systems. That combination lets the AI solve harder problems, get around limitations like context windows, and actually adapt to changing situations like the real world.
All right, let's nail down this definition then. Because agent isn't a new word in tech, right? We've had software agents for ages.
Yeah.
So we need to be super clear on what makes this agentic AI different. You mentioned that core trilogy, autonomy, initiative, and adaptability, chasing goals.
Exactly. That's the heart of it. It's critical to get that the agent isn't just, passively responding to a prompt. It's actively acting to achieve a goal. It pulls together the LLM's reasoning, yeah, but also planning components to break down big tasks, memory systems to keep track of things, and tools to actually do stuff in the outside world. They don't just follow one fixed path. They're designed to constantly check the context, see what's changed, and adapt how they're trying to reach the goal.
Okay, and this brings up a subtle but important distinction you flagged. The difference between agency and autonomy. People often use them interchangeably.
They do, but the distinction matters here. Agency is basically the system's ability to act, and maybe more importantly, to choose which actions to take from a menu of options. Autonomy, in this context, is more about the power to act independently, often without needing explicit human approval for every little step. So humans, we set the big strategic goal, the what. The agent then has the autonomy to figure out the exact steps, the sequence, which tools to use, the sub-goals needed along the way. That's the how.
And that how piece, that's where the initiative really kicks in. Like, if I ask a traditional system for market analysis, it just gives me data. An agent might realize, okay, first I need to hit this API, then check these 3 competitor sites, then synthesize that, then start writing the report. It figures out the workflow.
Precisely. And that's why the sources really emphasize drawing clear lines between agentic AI, generative AI, and, traditional AI. It's not just semantics.
Let's walk through that comparison then, just to make it super clear for everyone listening, starting with the old school.
Yeah.
Traditional AI.
Okay, traditional AI. Think things like classic robotic process automation, RPA. Its main job is automating tasks that are super repetitive, very predictable, low variability. So its autonomy is naturally low. It runs on fixed deterministic rules, like digital puppets following a script. If the input data changes unexpectedly, they usually just stop or break.
Got it. Then came generative AI, Gen AI, the one that really caught everyone's attention recently.
Right. Gen AI's main function is creating content, text, code, images, music. Its autonomy level is variable. It can generate really complex stuff, sure, but it fundamentally needs a prompt to kick off each generation cycle. And it doesn't inherently know how to connect its output to, say, external action tools. It learns primarily from digging through massive existing data sets. It basically waits for you to ask it something.
Okay. And now, Agentic AI, the star of today's deep dive.
Agentic AI, its function is different. It's about goal-oriented action and making complex, multi-step decisions. Its autonomy level is designed to be high. It's meant to operate with minimal human hand-holding once you give it the objective. And here's a key thing. Its sophistication often comes from a different kind of learning, reinforcement learning, or RL. That's a big differentiator in how it gets better over time.
Okay, reinforcement learning. We should spend a moment on that. How does an agent learn through experience and feedback?
Yeah.
How is that different from how an LLM first learns?
It's quite different. An initial LLM, it's usually trained on a huge static pile of data, like it reads the whole internet, basically, and learns patterns from that snapshot in time. RL, though, is dynamic. It's about learning through interaction with an environment. Think of it like training a dog with treats. The agent gets a task and a reward system. If it tries an action that moves it closer to the goal, like it successfully calls an API and gets the right data back, boom, positive reward, that reinforces that decision path. If it tries something that fails or causes an error, it gets a penalty. Negative feedback.
Okay, so instead of just learning passively from a giant library, it's actively figuring out what works in the real messy environment to get the job done. Trial and error, almost.
Exactly. It's constantly tweaking its internal policy or strategy for making decisions based on what happened last time. It shifts from being purely data-driven to being experience-driven. And that capability is absolutely essential because real-world places like your company's IT network or just the internet are always changing. Things break, APIs update. This continuous learning and adapting is what really enables that high level of autonomy needed for the whole do-it-for-me idea to actually work reliably. #3, the science and architecture of autonomous action.
Okay, so we get the goal, the learning approach. Let's peek under the hood now at the architecture. Our sources kept hammering this point. The LLM, the brain, provides the reasoning power, sure, but it's fundamentally stateless, like Dory from Finding Nemo. Every interaction is basically fresh.
Yeah, that statelessness is a massive hurdle for real autonomy. You can't manage a complex multi-day project if you forget everything that happened yesterday or even 5 minutes ago. So agents get around this. They become truly effective by adding specialized components onto the LLM core. We saw 3 main ones consistently highlighted across the research, beyond just the basic LLM reasoning.
First one, absolutely fundamental for any kind of multi-step task, memory.
Memory is critical, absolutely. And it works on a couple of levels. You've got short-term context retention, that's vital just to keep track of where you are within a single complex task that has multiple sub-steps. But then there's also long-term learning. This lets the agent remember things from past projects or interactions, what worked before, what failed, why. This stops it from making the same mistakes over and over or getting lost on some small detail and forgetting the overall mission.
Memory gives it history, continuity. Okay, the second component gives it reach, the ability to interact, tools.
Tools are the agent's hands and feet. They're how it interacts with the world beyond just processing text. And this isn't abstract. We're talking concrete integrations, calling specific APIs, maybe using a software license it has access to, querying databases, searching internal knowledge bases, hitting the web. Tools are what let the agent go from just saying what to do to actually doing it, deploying code, making a payment, updating a record somewhere. Without tools, it's still just a very smart chatbot.
Right. Brain, history, hands. And the final piece is the prompt, which acts like its mission statement or operating instructions.
Exactly. The prompt is the blueprint. It sets out the high-level goals the agent needs to achieve. It also defines the boundaries, the constraints. What shouldn't it do? It establishes the rules of engagement. For complex business tasks, the prompt might get quite detailed, including specific rules like never authorize spending over X amount without human approval or always log every action to this specific compliance database.
So LMN and brain, memory for history, tools for action, guided by the prompt. How does an agent actually sequence these things? How does it run its process? The source has laid out a pretty consistent 5-step workflow.
Yeah, it's like an autonomous operational loop. It kicks off when the agent gets a goal or a trigger. 1. Perceiving. First, it gathers data. What's relevant to this task right now? It might pull from different sources, could be text, but maybe even video or audio feeds, multimodal data, or structured data from internal systems. 2. Reasoning. Okay, now it thinks. Uses the LLM brain to understand the goal, figure out its current situation, break the big goal down into smaller, achievable steps, and critically, it generates a plan. This step gets a huge boost from something called chain of thought or COT training. 3. Acting. Now it executes the plan, uses its tools, calls that API, writes to that spreadsheet, sends that notification, deploys that code snippet. 4. Learning. This is the feedback loop, often using that reinforcement learning we talked about. Did the action work? What happened? It observes the result, gets feedback, maybe from the system, maybe from a human, and updates its internal strategy for next time. It improves. 5. Collaborating. And in more complex setups, the agent might share what it found or task it completed with other agents or back to human users. It can work as part of a team.
Okay, that reasoning step number 2, boosted by chain of thought training. You said that's a critical recent advance. It seems to shift the AI from just giving a quick, confident answer to thinking things through more slowly, more deliberately. Why is slowing down important?
It's huge. COT basically forces the agent to write out its reasoning step by step internally, like showing your work in math class. This deliberation, the slower pace, lets the agent spot potential errors or flaws in its own plan before it takes an action, especially before calling a tool. Tool calls can be expensive, slow, or sometimes irreversible. So self-correction before acting is key. It helps solve those tricky multi-layered problems that older, faster-reacting LLMs would just stumble on. It boosts reliability and cuts down on really bad mistakes.
Looking at the maturity levels, you mentioned most of today's maybe level 1 or 2. Basically better workflow automation. What does the dream level 4 look like? Full autonomy.
Level 4 is kind of the holy grail right now, the true digital colleague. The defining feature is the agent's ability to proactively set its own goals within its area of expertise. It observes what's happening, anticipates needs, and takes initiative, all with very minimal human direction. So instead of waiting for a developer to say, hey, optimize the app speed, a level 4 agent might notice performance lagging during peak times and just initiate an optimization plan itself. Find the bottleneck, test solutions, deploy a fix.
That really is a different paradigm. Now let's touch on the complexity we see today. Multi-agent systems, MAS. Why are companies often starting with teams of specialized agents instead of aiming for one super agent right away?
MAS makes a lot of sense currently. You have multiple agents, each may be optimized for a specific skill, collaborating on a bigger problem. It's classic division of labor. You might have one agent that's just brilliant at digging through databases, another that's a legal expert AI, a third that handles communications. This setup has big advantages right now. It scales well. It's robust. If one specialized agent fails, the whole system doesn't necessarily crash. A coordinator agent can maybe reroute the task. That's much better fault tolerance than one giant single point of failure.
So specialization and stability are the current wins. But our sources, specifically IBM's Chris Hay, is an interesting prediction about where MAS might go long term.
Yeah, that was fascinating. He predicted this kind of push and pull evolution. Right now, we start with MAS because building specialized agents is more achievable and reliable. But as the underlying single models get dramatically more powerful, maybe eventually able to handle many specializations, effectively the industry could swing towards these single, almost godlike agents that do everything end to end. Then maybe those super agents eventually hit their own limits on complexity or something, and the pendulum swings back towards needing collaborative teams of specialists again. It's not necessarily a straight line of progress.
That's a really useful framework, the push and pull. Suggests specialization might always have a role, even as the core models get incredibly smart. Hashtag Tag 5, 2025, trends, momentum, and real-world impact.
So why 2025 again? As we touched on, it's really about several key technical improvements hitting maturity at the same time, making these agents genuinely capable of reliable action in a business setting.
Let's quickly recap those four accelerants, maybe focusing on how each one specifically enables more autonomy.
Sure, first, better, faster, smaller models. They're just more efficient, cheaper to run per query or action. That makes it economically feasible to have them running continuously, taking actions. Second, chain of thought, COT training. That's the deliberate error spotting reasoning we talked about. Crucial for reliability in complex tasks. Third, increased context windows. Basically, much bigger short-term memory. The agent can hold on to complex instructions or lots of background info without getting lost mid-task. Hugely important. And fourth, function calling, or just better, more reliable tool integration, giving the AI solid ways to interact with external systems, turning its plans into real-world outcomes.
Okay, and these technical improvements are clearly driving serious investment. What kind of market scale are we talking about? The numbers were pretty eye-watering.
They are. The agentic AI market specifically is forecast to hit something like $52.6 billion by 2030. That's a compound annual growth rate, a CAGR, of around 45%, which is massive growth. And if you zoom out to the broader generative AI wave, which agents are a key part of McKinsey estimates, it could add between 2.6 and 4.4 trillion dollars in value annually to the global economy.
Trillion with a T.
Yeah.
That kind of number explains the urgency in boardrooms. But let me push back slightly. Is that growth just, taking existing automation spend and slapping a new label on it? Or is it genuinely new value?
That's a really fair question. And the analysis suggests most of that projected growth is from new value creation, enabled specifically by the autonomy. Think about it. Traditional automation handles the repetitive stuff. Agents tackle process orchestration, coordinating multiple steps across different systems, and complex, dynamic decision-making, things that simply weren't automatable before. Gartner kind of backs this up. They project that by 2028, at least 15% of all work decisions, actual operational choices, not just tasks, will be made autonomously by agentic AI. That's up from basically zero today. It's a shift from automating tasks to automating decisions.
Okay, that clarifies the value proposition. Let's get concrete. Specific use cases where agents are moving out of the lab and into real-world productivity. The most meta example first, software development itself.
Right, the autonomous software engineer. The big name here was Devin from Cognition Software. Devin was pitched as being able to handle coding jobs end-to-end without direct supervision, scoping the task, writing code, debugging, designing apps, even training other AI models. It acts like a single agent managing that whole complex lifecycle.
And how did it actually perform?
Sure.
Compared to humans, or even the best coding assistants we already have?
Well, in tests against real GitHub issues, actual bugs, and feature requests from open source projects, Devin managed to resolve about 14% of them completely on its own. That was roughly double what previous LLM-based tools could do, so a significant improvement. But, and this is important nuance, it still struggled with problems needing really deep understanding across multiple code bases, or complex strategic refactoring, or just figuring out what a human meant in a vague bug report. So it shows huge potential for efficiency gains, definitely. But it's not replacing experienced human developers wholesale just yet. Far from it.
Okay. We also saw examples closer to home for many companies. Internal IT automation, like at Amazon.
Yeah, Amazon used their own Amazon Q developer agents internally for a notoriously painful task, upgrading Java versions across thousands of applications. This is usually a massive time sink for developers, super tedious and prone to introducing errors. They managed to automate large chunks of this process across tens of thousands of production apps. The value prop is clear. Free up expensive human developers from that kind of maintenance grind to focus on building new features.
Makes sense. Now, healthcare. Higher stakes, obviously. Speed is often critical. Tell us about the Genentech example.
Genentech built an agentic system using AWS tools aimed at speeding up drug discovery, specifically automating the incredibly time-consuming manual search needed for biomarker validation. This involves trawling through enormous amounts of scientific literature, both public and their own proprietary research. Their agents are pretty sophisticated, using a technique called R.
Okay, hang on. RAG. Let's quickly define that for listeners who might not know the acronym.
Sure, RAG stands for Retrieval Augmented Generation. It's a clever technique. It lets the LLM, the agent's brain, first go and retrieve relevant, up-to-date information from specific, trusted knowledge sources. So for Genentech, that might be their internal research database or approved medical journals. The agent pulls out the grounded facts related to the query. Then it uses those retrieved facts to generate its answer or report. The key benefit: it stops the agent from just making things up, hallucinating, based only on its general training data. It ensures the output is grounded in specific, reliable, often proprietary information.
Got it. So the Genentech agent uses RAG to query multiple vetted knowledge sources, break down complex research questions, maybe hit some internal APIs, and find connections much faster.
Exactly. It cuts down the time needed to explore potential drug targets dramatically. Instead of a highly paid scientist spending weeks reading papers, the agent can deliver a synthesized, evidence-backed report in hours.
Huge potential there. Let's switch gears to customer support, an industry known for high stress, high turnover.
Yeah, customer support is almost a perfect fit for Agentic AI's strengths. Where traditional chatbots fall over is usually when a customer's problem requires multiple steps or touches different systems. An agent can handle the whole life cycle. Imagine a customer calls about a billing mistake. The agent can understand the issue, query the billing system to confirm the error, use an API call to fix it, trigger a refund process, and update the CRM record with details of what happened, all potentially without a human needing to intervene. This frees up the human support staff to deal with the really complex, sensitive, or emotionally charged issues where empathy and judgment are paramount. It could significantly reduce the churn and burnout in that sector, which our sources pegged at a staggering 38% annual turnover.
Wow. Okay, one more key area, regulatory compliance. Always a headache due to volume and complexity.
Compliance is definitely a big growth area for agents. There are startups building agents designed to read and understand complex, constantly changing regulations. They can then compare those regulations against a company's internal policies, procedures, and documentation. The agent can quickly flag potential non-compliance issues, point to the specific regulatory clause, and even draft reports for human compliance officers to review. This is vital because complexity in keeping up with rules is often cited as a major barrier to deploying AI more broadly. Agents can help manage that complexity.
And all this rapid development and deployment, it's getting a big boost from the open source effect, right? How is having powerful models available to everyone changing the game?
It's a major factor. When really capable models like xAI's Grok 1 or models from innovative companies like Moonshot AI in China get open-sourced, meaning the code and the model weights are released publicly, it really challenges the dominance of the big, closed-source players. It dramatically lowers the cost and barrier to entry for smaller companies, researchers, startups. They don't need multi-billion-dollar supercomputers to experiment and build sophisticated agents. It fosters innovation everywhere.
And you mentioned a global accessibility angle too, especially with text-based interaction.
Yes, because these agents fundamentally operate on text input and output, they can potentially be accessed even through very basic technologies like SMS text messages. This is important for accessibility in parts of the world, particularly the global south, where reliable high-speed internet isn't a given. It means the benefits of AI aren't necessarily restricted only to places with advanced digital infrastructure, #TagFOMV, navigating challenges and governance imperatives.
Okay, we've painted a picture of huge potential rapid momentum. Now, the reality check, the challenges. We need that healthy skepticism Deloitte advised. Is this shift truly as revolutionary as claimed? Or is it, just a fancier way of doing complex automation we were already heading towards?
That skepticism is crucial. And yes, some experts do argue that for the really tricky, nuanced decision-making, the tech still has a ways to go, needs maturation. Agents are getting good at complex workflows, following intricate steps. But when it comes to truly ambiguous problems, like, say, interpreting a rival company's subtle strategic shift based on patchy information, the risk of the agent getting it wrong or acting out a hallucination is still significant. So enterprises need to be realistic. Start with the simpler, well-defined use cases. Get those right. Build trust. Then cautiously scale up to more complex, higher-stakes applications.
Let's talk about the human side of this, the whole augmentation versus replacement debate. The standard corporate line is usually, oh, it'll augment workers, not replace them.
That is definitely the prevailing vision, and it makes sense. Agents are really good at the repetitive, data-heavy, cognitively taxing but low-value tasks. The idea is this frees up human workers for what humans do best: strategic thinking, creativity, complex problem-solving, negotiation, empathy, the stuff agents really can't do.
But there's a flip side risk, isn't there? That the relationship gets inverted.
Absolutely. There's a real danger if these systems are implemented poorly. If they're clunky, hard to manage, constantly need their outputs checked and corrected, then the human worker ends up just babysitting the AI, spending all their time validating data, fixing errors, basically becoming a support system for the agent. We saw this term the risk of humans augmenting the AI. Instead of the tech serving the human serves the tech just to keep the automated process stumbling along. That completely defeats the purpose and kills morale.
Which is precisely why human in the loop, HITL, comes up again and again as essential.
Non-negotiable. Especially for anything high stakes or where a mistake is irreversible. Think healthcare decisions, major financial transactions, legal judgments. A human must be the ultimate decision maker in those loops, bringing ethical considerations and critical thinking. The sources also suggested a slightly different model for lower risk tasks. Human on the loop, where the human isn't approving every single action beforehand, but periodically reviews batches of automated decisions after the fact. This helps build trust, allows for auditing, before maybe moving to more autonomy later.
Okay. The biggest challenge tied directly to autonomy, though, has to be accountability, the black box problem. If an agent acts independently and messes up badly, who's ultimately responsible?
Yeah, that's the crux of it, legally and ethically. A piece of software can't be held responsible in a court of law or in the court of public opinion. Accountability always rests with a human, the developer who built it, the manager who deployed it, maybe even the CEO. And the scale of risk gets amplified dramatically with autonomy because agents act at machine speed. If an agent designed to, say, clean up old customer data, misidentifies a pattern and deletes thousands of active sensitive records instantly, the damage is done before a human might even notice.
So if the tech can act faster than human oversight can react, then traceability becomes paramount, knowing exactly what it did and why.
Exactly. Traceability means being able to reconstruct the agent's entire decision process. What data did it look at? What was its internal reasoning chain? Which tools did it call? What was the result? This requires really comprehensive logging of everything, every step, every data point accessed, and it means agents absolutely must be put through rigorous testing in safe, sandboxed environments first. Stress test them, throw weird data at them, simulate failures, try to anticipate how things could go wrong before you let them loose on live systems.
Given these stakes, just adopting the tech isn't enough. It has to come with a serious governance strategy.
Yeah.
And regulations are starting to force this issue, right?
They are. Global regulations, especially things like the EU AI Act coming into force, are pushing companies hard. They have to implement formal governance frameworks now. This legislation demands clarity on things like bias detection, transparency in how AI makes decisions, and clear lines of accountability. For agentic AI, this translates directly into needing clear guardrails. What level of autonomy is okay for which types of tasks? How do we ensure we can explain why an agent made a particular decision?
Let's connect that to the autonomy levels we discussed earlier, level 1 to 4. How might those map onto something like the EU AI Act's risk categories? Which levels are likely high risk?
It's a strong possibility that applications going beyond level 2, which is mostly just automating predefined workflows, and into level 3 or level 4 territory, those are very likely to be classed as high risk, especially if they're used in sensitive areas: employment decisions, credit scoring, law enforcement, healthcare diagnostics. Being designated high risk under the Act triggers a whole set of strict requirements: mandatory human oversight, detailed risk assessments, proof of data quality, robust monitoring. It basically puts the brakes on just deploying fully autonomous agents without extremely careful planning and justification.
So governance isn't optional. It's becoming a legal prerequisite that actually shapes how fast you can deploy. What should companies be doing now to get their data house in order to become agent ready?
Job number 1 is achieving data readiness. Agents are powerful, but they're only as good as the data they can securely access and act upon, especially proprietary internal data. So enterprises need to get serious about organizing, cleaning, standardizing their own data assets. And crucially, they need to make that data accessible through secure, modern APIs. Transforming those internal data systems is probably the biggest foundational step needed to actually enable useful agentic workflows and get a real ROI. If the agent can't reliably get to the right internal knowledge, it's basically crippled.
And assuming the data is ready, what's the recommended strategy for actually rolling out agents? Balancing the excitement with the risk?
The consistent advice is risk balancing. Start small, start safe, deploy agents first for low-risk tasks, maybe using non-critical data. Implement strong, human-on-the-loop oversight initially. Use these early projects to build internal skills, figure out your auditing processes, and build confidence within the organization. Then, once you've proven the value and safety at that level, you can gradually start moving towards higher value and more complex, potentially more autonomous applications. Walk before you run. And we should also briefly touch on the sustainability angle. It came up in the sources too.
Right. The sheer amount of energy needed to train and run these huge models, it's significant, equivalent to many households' annual electricity use sometimes.
It is, and that's driving a real push towards green AI. Research into making the models themselves more energy efficient is one part of it, but another critical aspect is looking at the power source for the data centers themselves. There's growing interest in reliable, low-carbon energy, specifically citing things like nuclear power, maybe even small modular reactors, SMRs, to provide the constant clean electricity needed for these massive, always-on AI workloads. Hashtag tag chick6i4. Conclusion and final thought.
Okay, wrapping this up, this deep dive really confirms it. Agentic AI isn't just lab research anymore. It's actively making the jump to becoming core business infrastructure. To sum up, this tech looks set to genuinely redefine how work gets done. It blends that advanced autonomy, the planning and acting, with human oversight and expertise. It opens the door to tackling incredibly complex, multi-step business goals in new ways.
But success, especially hitting that 2025 turning point effectively, absolutely depends on balancing the drive for innovation with a serious brace of responsibility. That means robust governance, clear ethical lines in the sand, and strong security to ensure we know what these agents are doing and can hold someone accountable.
And this really recasts the role of the technology leader, the CIO perhaps. They're not just keeping the lights on anymore. They need to be the orchestrator of this new human-AI collaboration. They have to craft a strategy that encourages innovation out in the business units, but within firm, consistent guardrails that prevent things from going off the rails with runaway agents.
And maybe the key takeaway for everyone listening, regardless of their specific job title, is that career relevance in the near future might depend less on deep expertise in one narrow skill and more on your agent literacy, your ability to effectively supervise, collaborate with, and strategically direct these autonomous systems, almost like managing a new type of team member.
That line between tool and teammate, it's getting blurrier incredibly fast.
Yeah.
We're heading towards systems that act like proactive partners, even though we know they don't have consciousness or actual moral understanding.
Exactly. And as we establish, the responsibility, the accountability always stays with the humans. But the mechanisms for ensuring responsible behavior have to be built into the agent's design and the systems around it.
Which leaves us with a final thought, something for you to ponder as we get closer to that level 4 autonomy ideal. Given that these agents are designed to operate independently, maybe even setting their own sub-goals, how do we, as organizations, build the auditing systems, the control mechanisms, to guarantee that their autonomous actions always align with our human ethical principles and constraints? How do we ensure they never optimize for pure efficiency at the expense of the safety or well-being of people, employees, or customers?
It really is the ultimate governance puzzle for this century, isn't it? How do you ensure the machine's goals stay aligned with human values, especially when it's operating on its own?
A huge, urgent question for this next wave of automation. That's all we have time for in this deep dive.